Okay, today I would like to discuss about past question chapter 10 applications. How to answer this application of differentiation question. First of all, we have to identify or recognize the important methods to this question. Past 2013-2014 question number 6. A cylindrical container of volume 128 pi meter cube is to be constructed with the same material from the top, bottom, and lateral side. Find the dimension of the container that will minimize the amount of the material needed. Alright, how we do this? The next step is we have to construct the mathematical statement. A cylindrical container, so we have that the can is the cylinder, alright, and we have that the keyword is the volume. Okay, usually we denoted that the volume by the V, so V equals to 128 pi meter cube. Next is we construct that the same material of the top, so the top and bottom. Okay, this is the top and this is the bottom, and this is the lateral side. The question is asking us to find out the dimension. What is the means of the dimension? Okay, when we discuss about cylinder, the dimension here is denoted by the R, where is radius of the cylinder, and the height of the cylinder. That means we have to find out the R and H, where is when this container have minimized amount of material needed. To construct this cylinder, we also must to consider the area of the cylinder. So we come up with the formula of area to the cylinder. Area, usually we denoted by the A. So this is equals to the top is the circle. Okay, for the area, this is a circle. So we have pi r square. And for the bottom, this is circle. So we have pi r square. Therefore, we need to times by 2. So we have 2 pi r square for the top and bottom. The next one, we have to plus to the lateral side, what is 2 pi r h. Don't be so much worry. In your final exam, this formula of cylinder will be given. Next formula we have to be considered is the formula of volume cylinder. Volume cylinder is equals to pi r square h. So from here you have 128 pi. So we just add here 128 pi is equals to pi r square h. Next process, what we have to do is we need to have the minimized amount of the material. So from here we can have that the minimum of the area. Okay, to construct this cylindrical container, so we have to consider the area of the cylinder, what is R and H. So to find out the minimum or the maximum or minimum of extremum, we have to differentiate the formula of area. So how to differentiate this formula? Okay, we must make sure that the equation must be in terms of one variable. So the variable of A, okay, one variable A is okay for the left hand side. 2 is a constant, pi constant, 22/7, okay. So we have R square, this is a variable where it's unknown, and 2 constant, pi constant, 22/7. R is a variable where it's unknown, and H of the container is also don't know. So from this statement, from this equation, you have one variable A to the left and 2 variable of the R and H to the right. So this is not proper. You must do write it down area in terms of the one variable only. But by referring to this original, what is the first statement, you can have that where is pi and pi can be cancelling. So now we have 128 equals r square h. From this one, we can transform or manipulate to have where is r square equals to 128 divided by h, or we can have that the h equals to 128 and divide by r square. So we need to consider these two, okay? Manipulate the r square or h square. But class, you have to choose the correct one. You have the a, so we have no problem with variable a. Next is you have one variable r to the first term. And for the second term, why not we shift or swap the h in term of r? Equation of area equals to 2 pi r square plus 2 pi r h. Now, we change a equals to 2 pi r square plus 2 pi r, and h now is 128 divided by r square. Next, a equals 2 pi r square. Then this is the plus to 256 pi and divide by r. Now this equals to r power negative 1. Now you can differentiate this equation of A now, what is respect to R. So we have differentiate of the area respect to R, dA dr now equals to 4 pi R, and you have that this is a minus, okay, because these are power rules. This is a minus 256 pi R power of negative 2. To have the minimum or extremum, the first derivative must be equal to 0. So we equate 0 here. We have 4 pi r minus 256 pi and divide by r square. Next, we have that this equals to 256 pi divided by r square equals to 4 pi r. Pi and pi will be cancelled. Then we gotta have that where is r cubed equals 64. Then r equals 4. When r equals to 4 is not yet the maximum or minimum. Okay, this is just a critical number. Okay, how to confirm that this is a minimize? Let's differentiate the first derivative. Let's check it by using the second derivative. Differentiate one against the formula of area respect to r. This equals to 4 pi plus 512 pi r power negative 3. This is equivalent to the second derivative. This equal to 4 pi plus 512 pi divided by r cubed. Now you have that this is a critical number. Okay, we substitute this equation. So we have 4 pi, okay, plus 512 pi and divide by 4 power 3. And this equal to 4 pi plus 512 pi divided by 64, where is we confirm that this is a second derivative greater than 0 when r equals to 4. When the second derivative is greater than 0, so this is a minimum problem. Okay, so what we can say that this is the area is minimum when r equals to 4. So this is the dimension for r. Let's calculate the dimension of the height. Okay, h equals to 128 divided by r square. So r equals to 4. So we can have that is a 4 power of 2. Next, the height equals to 8. So this is the dimension of the area when the dimension of the radius equals to 4 and h equals to 8, where it gives us the area is a minimum. Don't forget, let's put down the unit. So let's do for the questions. This is a meter. Okay, so put down that this is a 4 meter, this is 8 meter. Done. B. Gravel is dumped onto a flat ground at the rate 3 over 20 meter per minute to form a conical shaped pie with the vertex 60 degree as shown in the diagram below. Compute the rate of change of the height of the conical pie at this instant when t equals 10 minutes. Identify our keyword. You have that the keyword of rate. Rate must be related to time. So this is a respect to time. Next is you can see that this is the unit of meter cube. That means this is the volume equals to the rate of volume equals 3 over 20, where is this a meter per minute, meter cube per minute. Alright, now we already construct the first formula. Second, alright, we have given that this is a conical shaped pie, where is 60 degree. Every time you have the cone shape, so you have that this is a, okay, if they have been mentioned clear, this is 60 degree, so we notice that this is 60 degree. If you not be mentioned any 60 degree or any angles, we can have that, or we can assume that this is equals to, okay, 90 degree or semi equals to 45 degree. Okay, let's focus on this question. Now you have been given that the vertex have 60 degree. Okay, every time if you have that, this is what we call that the cone, you can have its ratio, whereas you can have the trigonometry ratio, whereas in the semi, so you have that this equal to 30 degree. This is the height of the gravel, and this is the radius of the gravel. Alright, now what you have here, you have the ratio in a degree, so we have that side where is side opposite and divide by adjacent. This is the can we have that the tangent. Okay, so side opposite divide by adjacent, so you can have that the tangent. So we can construct that tangent 30 degree equals to r divided by h. Where is tangent 30 degree equals to 1 over sec 3. Okay, so we have 1 over sec 3 equals r over h. From here, we can manipulate to have that r equals 1 over sec 3h, or we can have that h equals this is equals to sec 3r divided by 1. So you can have that either r in terms of h or h in terms of r. Okay, how to know that? Okay, let's refer this question. Compute the rate of change of the height. The question is request to have the height. Okay, the next equation that we need to consider where is the volume equation. Okay, the equation before we differentiate where is the volume. Formula of the volume equals to 1 over 3 pi r square h. Okay, this formula is not harmony because we have many variables to the right hand side, where is one variable to the v and two variables to the where is right hand side r and h. So let's have the single variable to get that the h, okay, in term of h. By referring to this case, okay, you have that where is h in term of r and r in term of h. So let's use the r in term of h. So the new formula of the volume now, where is the volume equals 1 over 3 pi r square. Now r is 1 over sec 3 h square and times to the h. Now this equation is a harmony because v is only in term of h. Alright, let's go and let's solve this question. Alright, so let's go. We have that the volume now equals to 1 times 1 is 1 divided by 3 times the 3 square. So 3 square is a 3, so 3 times by 3 is equals to 9. And you have that pi, h squared times by h, you have the h cubed. Okay, let's differentiate the v in terms of the h. Okay, so we have that the v, okay, dv dh equals to, right, so we have that this is 3 times 1 over 9. Next, you have that pi h n square. So we have dv over dh equals to 1 over 3 pi h square. All right? Construct the rate of the height. Okay, we want the rate of the height. The rate, okay, dh dt. Okay, so let's construct this formula. So the first thing is, okay, that we have that these two formulas now. Okay, where this is dv dt and this is dv dh. Okay, let's construct this. Where is now you have that this must be dv over dt, because this over dt must be same, right? Next is need times to the, this is the must be, this is must dh as our denominator. Okay, so denominator is dh over dv. Then dv dt is 3 divided by 20 and times dh dv. Okay, so this is dv dh. We just swap this case. So you have that this equals to 3 divided by pi h square. This is not done yet because these are already in terms of the h. So you have to calculate the h. Okay, the value of h at t equals to this original, where is the volume equals to 3 over 20. This is a meter cube. When you have that, this is 1 minute. Now we have 10 minutes. How we solve this? So the volume equals to 3 over 20, then times by 10. So we have 3 over 2. All right, how we do this? Let's find out the h. So this is your h. Where is the volume now? Is 3 divided by 2 equals 1 over 9 pi h cube. Then we have that the pi h cube equals 3 over 2 times 9, and h cube equals to 27 divided by 2 pi. Then h equals to cube root 27 divided by 2 pi. Let's substitute this value to the green color. Equals 3 over 20 times 3 divided pi. H is cube root 27 over 2 pi and square equals dh dt 0.0542 in unit, where is height is meter per minute. Done.